Alright, this is 5.8, and in this section we're solving equations that are full of fractions. And at first people get really discouraged when they look at this and see these fractions, but then there's such an easy way to deal with it that we learn that, and it makes it not hard at all. Now, if we were to try to solve this, one of the things that we could do, we could get a common denominator, but that would take a long time. So what we do is this. We look and we see 9 and 6 and 3, and we think, what is the smallest thing that 9, 6, and 3 all divide into? Let's say you have a hard time coming up with that. What I'm asking you to do is to find the least common multiple, and in the previous sections that we did, that least common multiple would have been the common denominator that we'd have used if we had actually tried to add or subtract fractions. But if you've forgotten how to find the least common multiple, you write the numbers down and you write down their factors, their prime factors. 9 is 3 times 3, 6 is 2 times 3, and 3 is just 3. And you take each factor the most number of times it occurs anywhere in all those, okay? So for instance, 2 occurs, but it only happens one time. It's not even in 2 of the numbers, but because it occurs in one of the numbers, I have to write it down. Now let's look, there's 3s. There's 2 3s here. There's only 1 here and 1 here, but I want to take it the most number of times it occurs in any of those numbers, and the most number of times it occurs is twice. So I have to write it down as 2 3s. So what is that number? 2 times 3 is 6 times 3 is 18. Oh, my least common multiple is 18. So what I do is I'm basically just going to multiply every single term in that equation by 18, and that will clear the fraction out. So for instance, I'll say 18 times x over 9 plus 18 times 1 over 6, and then I'll multiply 18 times 2/3. So don't forget every single term, okay? Well, let's go simplify this, and let's see how this helps us. 9 goes into 9 once, and it goes into 18 twice. Oh, that whole term just became 2x. If you look at the second, we put the plus sign down and look at the next term. 6 goes into 6 1, and 6 goes into 18 3 times. Oh, that's just 3 times 1 is 3 over 1. That's just a 3. See how all the fractions just vamooshed. Okay, now here 3 goes into 3 1, and 3 goes into 18 6 times. That's just 6 times 2, which is 12. So if I want to solve this, all I have to do is solve this simpler equation, and it's the same equation. It's just much easier to look at now, isn't it? So we would subtract 3 from each side, and we would get 9 over here. And then you get 2x is 9, and if you divide both sides by 2, you get x equal 9/2, and you can just leave your answer like that. It's not a fraction that will reduce, so we just leave our answers as fractions. X is 9/2. All right, number 5 looks much the same way. It has all these fractions. We're still going to clear the fractions out. The only thing different here is we don't have an equal sign. We have a less than or equal sign, but if you remember what we do is we just solve it the same old way, and then if we end up dividing by negatives somewhere, then we have to make sure we flip the inequality sign. But it's really not anything different than a regular equation except for that one little thing. All right, so 4, 6, and 12. Don't all of those divide into 12? They do. So what I'm going to do is I'm going to multiply each one of these terms by 12. And that will clear my fractions out, just like it did in the last problem. Okay, now if we go canceling stuff out, 4 goes in there once, 4 goes into 12 3 times, and 3 times z is just 3z. 6 goes into 6 once, 6 goes into 12 twice. So now I have to distribute this. Negative 2 times z would be a negative 2z, and a negative 2 times a negative 1 would be a positive 1. So I'm just going to go ahead and distribute while I'm at it. And then on this other side, the 12s just cancel out and leave me 5. 12 goes into 12 once, 12 goes into 12 once. 1 times 5 is 5, 5 over 1 is 5, right? All right, so let's simplify. We have on the left-hand side, we have 3z minus 2z. Well, that's just a 1z. I have z plus 1 is less than or equal to 5, so I subtract 1 from both sides, and I get z is less than or equal to 4. Now, that's the solution. Z is less than or equal to 4. We sometimes in times past had to graph that. It didn't tell us we had to here, so we are not going to. We're just going to leave it like that and be happy. Oops, I must have messed up somewhere. See, in the book answer has Z is less than or equal to 3, so let me look at that. Oh, I caught my mistake. Do y'all see it? It was up here, negative 2, when I distributed this negative 2. Negative 2 times Z is negative 2Z, and negative 2 times negative 1 is a positive 2. So it should have been z plus 2 is less than or equal to 5. So I would subtract 2 from each side, and that would give me z is less than or equal to 3. So I just forgot to distribute the 2. When I multiplied, I did the negative part, but I forgot to do negative 2 times negative 1. So anyway, our answer here should be z less than or equal to 3. I just made it an error distributing there, so just be aware of that. And if you were confused before, now you see that you were right and I was wrong. All right, on number 9, this one's not going to take too long. If you look, maybe it would help you if I put 2 over 1. I don't know. You can do that, or you don't have to. If you want to make them all fractions, you can. You didn't have to do that. But you look at all your denominators. You basically have a 4 and a 2, and then I added that 1 in. What number will 4 and 2 both divide into? Well, you want to pick the lowest number, so we're going to pick 4, okay? So what I'm going to do is I'm going to multiply every single thing here by 4, even the 2 down here. Don't forget the 2. And then over here also by 4. All right, so what we get is 4y squared over 4. Well, those 4's would cancel out, and I would just be left with a y squared. I could say 2 goes into 2 once, 2 goes into 4 twice. So negative 2 times 3y would be a minus 6y. And then here's my plus sign. 4 times 2 is 8, and it's equal to 0. All right, you got a square. How are you going to solve a square? Well, we'd like to factor it if we could. And so that's what we're going to try first. And if that doesn't work, we'll have to go do the quadratic formula. We're trying to find two numbers that add to give 8. Multiply to give me 8, the number on the end, since it's just got this little 1 in front of the y squared here. And then they add to give you a negative 6. Okay, so we know that, how about negative 4 times negative 2 is a positive 8, and negative 4 plus negative 2 is negative 6. This factors very nicely. We put the y here and the y here, and we have a minus 4 and a minus 2. So now if I want to solve this, because it told me to solve it, I take each one and I set it equal to 0. So I take y minus 4 equal to 0, and I take y minus 2 equal to 0. And if I solve, I get two answers. I get y equal 4, and I get, over here, if I add 2 to both sides, I get y equal 2. So if I want to list my answers in the fancy set brackets, I would get, I would probably put the 2 first and then the 4, to just listing them least to greatest. And that would be my answer. Make sure you circle your answers. Try to write your answer in set notation when you get a list like this. 11 on this video. And number 11, is that right? Is the last one assigned? Let's see, how about 15? Let's go to 15, sorry. I don't want to do the really, I'm just trying to pick some of each one. Okay, we get y times 2y minus 1 over 2 equal 1 minus y over 3. Now there's two ways I can solve this. I can solve this one just like I did the others. If I want to do that, I could multiply both sides by, let's see, what do 2 and 3 both go into? Don't they go into 6? You can do it that way, okay? And that's the way we've been doing all the other problems. Another way, and I'll leave that one for you to do that way, because I think you could probably handle that. I wanted to bring up another way to solve this. So method 1 would be to multiply both sides by 6. Method 2, if you look, I have a fraction equal a fraction. What I could do here, this basically is a proportion. When you have two fractions set equal to each other, it's a proportion, and you can cross multiply. So that's what I'm going to do here, just to show you a different technique. You could multiply both sides by 6, and if you want to do it that way, you're welcome to. But I just want to show you that this happens quite a bit in math, and so we use this a lot. Let's say I multiply that first diagonal. 3 times y, 2y minus 1 would be the first diagonal if I cross multiply. And then if I multiply the other diagonal, it would be 2 times 1 minus y. Okay, so now let's just simplify all this. 3y times 2y is 6y. 3y times negative 1 is minus 3y. All right, on the other side, 2 times 1 is 2, and 2 times negative y is negative 2y. Okay, let's clean up. Ooh, this was a 6y squared over here, and I didn't put it there, or I wrote it and it didn't show up. But 3y times 2y over here should have been 6y squared, okay? That's going to make this a harder problem, because I can't combine 6y squared and 3y, can I? And so since I got a square, I know that usually whether I factor it or whether I use the quadratic formula, I need to move all the terms to one side and have 0 on the other side. And I also know that I always want a positive y squared term. So I'm going to leave 6y squared by where it is, and I'm just going to subtract 2 from both sides. and then add 2y to both sides. I'm just going to move both of those over in one little step here. That would be 0 and that would be 0. That would give me 0 on the right hand side if I'm just moving them all in one step. Alright, let's clean this up. We have 6y squared. I have a minus 3y plus a 2y. That would be a minus 1y. If you want to put it in there, you can. I'll just put it kind of dotted in there. And then I have a minus 2. And I'm hoping this factors. Okay, so let me try it and see. Now, I'm going to try guess and check on this one. You could go do splitting middle term if you wanted to. I'm going to try guess and check because I think with 6y, a lot of times it's 3y and 2y. And I've got minus 2. Let's see. I want to have a difference of 1. Now look at what if I did this? I would have a 4y here and I would have a 3y here. If I want a minus y, I need the 4y to be negative, so I'll put a negative there. And I would have the 3y be positive because minus 4y plus 3y would be minus y. I could factor it that way with guess and check. Okay, so now those are my factors. That actually works. You could, again, have done it with the split in the middle term if you wanted to. But I've got to solve now, so I'm just going to go ahead and take this and set each one equal to 0. I've got 2 to set equal to 0, and I'm running out of space, so I'll just do it like this, okay? If I add 2 to both sides, I'd have 3y equal 2. And if I divide both sides by 3, I would have y equal 2/3. Let me list my answers up here since I'm out of room. I'm going to put my little brackets up here and circle it. Now let's do the next one. If I subtract 1 from both sides, I'd get 2y is negative 1. And divide both sides by 2, I'd get y is negative 1/2. So I could list them up here. Probably in the book it's going to be listed negative 1/2 and 2/3 because negative 1/2 is smaller than 2/3. I just kind of ran out of room there. Anyway, but those are the two answers. You just want to put them in the correct order.